Okay, so we had some of you solve the issues and we got a way better game now. So I haven't merged one last thing, which I unfortunately haven't yet had the time to merge. There are 3 PRs outstanding, 2 have conflicts and 1 is ready to merge, but this is without either of the 3. And now the camera moves smoothly. We have 2 players and the players are actually independently animated. So the real 2 players. So this sounds like a good starting point for a game. So this time we're going to go into the Servant implementation. We're going to see how it works. We're going to see how the WebSocket communication works. Then we're going to bind the front end to the back end, and then we're going to let you loose on actually, adding more features or whatever. It's good that I've actually tested it because it turns out the backend didn't compile because I just wrote it and I never ran GHC. So I fixed it today, which is nice. So if you
having some compilation issues.
Yes, then git pull.
I did. After that, I'm having compilation issues. So when I run npm run start, it works fine, but npm run div does not work. It says
in the front end, then you just need to npm install.
okay.
You're probably missing some packages. But I'm mostly talking about the backend here. So the backend is in the server side path. You can check it out where you want. It's also kind of all of the things thrown into one jar just to make it simpler to write. So first we need some compiler extensions to get the type families added. So basically what we're doing in the backend is we're having a set of users that are authorized. The users can authorize themselves, but the user needs to be authorized to actually go in the server. So we'll store the users like that. They have a username, they have a unique ID, and then they have a score counter. It's totally not secure. The users can update their own score, but we trust them to do their thing, and this is the way to get millions of dollars like PUBG did. So we need the 2 JSON instances for the data types to actually serialize them to the front end. We're also storing the state of what users have registered on our server in ACID state. Those are these template Haskell directives. You can basically ignore it, apart from, you'll see how it works. We get automatic ACID storage of our data types without any database, which is super neat. I love it. We can add the user. We just get the state and we append another user into our set of users. We can get all of the users and we can update a given user. So we remove the old instance of the user and we replace it with the new instance. There is an account creation request where you say your username and the server will return a unique ID for that username. It doesn't do any checking if that username already exists. It trusts the user. So we get to the servant part. With servants, you write your API on the type level. This way, it allows checking if your API is correct, if your functions work with that API, and it also does a lot of neat things, like you can generate Swagger files from the API definition, you can generate documentation from the API definition, you can generate JavaScript clients, and I don't know if you can generate other clients in other languages, but it would be similarly easy to implement. So what does an API definition contain? Well, it has a path here. So this is basically /register. And then we use this chaining operator to add different functionality. This is all on a type level. So this is a type level operator. So we're going to need access on the register endpoint to the body of the request. and the body will conform to the account request type. So it's going to be an object, a record in Haskell. They'll have a username field, and we say we are going to accept the JSON format. There are other formats that are built into Servant, and you can also add your own formats if you want. We're going to communicate using JSON because that's the sanest thing to do with the front end. But you're in no way limited. And Servant does all of the boring stuff for you, so you don't have to check the type. If someone provides a wrong type or a type that doesn't deserialize, it'll return the error to the user, and you don't have to take care of that at all. So on that request, we're going to get the body, and then we're going to send a response that's also going to be serialized into JSON. It's going to conform to the account type. So the account type we've defined over here. So this is our unique ID, our username, and the score, which by default is going to be 0. Then we are having another endpoint. We define another endpoint using this alternative combinator. And we can define as many as we wish. As far as last time I've checked, a couple of years ago, this was doing linear complexity routing. I think it's logarithmic now, but I'll have to check again. So on the user's endpoint, it's just a GET request. We don't really care about the body. We're just going to return all of the users. So we're going to return a set of accounts. This is going to be serialized into a list. And all of the serialization, as long as there are 2 JSON instances on the types, is going to be handled for us. Because this is on a type level, we're going to get an error if we don't have those instances. So basically, if our API compiles, we can be more or less sure it does a more or less good thing, right? And then the last endpoint is going to be the score endpoint, where users will be able to put and update their own score. We're going to capture a UUID parameter. So in other frameworks that don't have this functionality, you'd usually write it like this. So this is a path parameter that we call UUID, and it's going to be automatically deserialized into a UUID type. And if the deserialization fails, the error is going to also be handled completely outside of our view. We can, of course, modify it, but we don't have to, tire ourselves of validating data types. This is done completely for us. That to-do is completely out of date. And then we have the API, and we have to provide the implementation, right? So we have to actually say what those endpoints are going to do. We do it with the server function here that's going to return the server API. This is what we need. It's going to also accept state in our case, but we're looking for that type. This is a type that's going to describe the implementation of our server. And the implementation is separate from the API in the sense that it's not actually, sorry. I just wanted to say that you can have an implementation for multiple APIs if those APIs are the same, but then it's isomorphic, so it's basically the same type, so it doesn't really matter. Anyhow, for our register endpoint, we're going to get a random UUID. We're going to create an account, and then we're going to update the state of all the users, and then we're going to return the account in the server monad. And this is going to be serialized completely automatically using ASIN. For all the users, effectively, we're just going to get the set of all the users and lift it into the IO monad. For the score, we're going to, for the update of the score, we're going to find the user that has a given UID, and then we're going to update it. And we're going to return nothing since we're modifying. Because you can't just pass around types in Haskell, we need the proxy type. So the proxy is an object that does nothing. It only has a type of the APIs. This allows us to actually pass this type around as a label. This to-do is also widely out of date. So once we have the proxy, we pass it to the serve function, so serve knows what's the type, and it can then operate on that type. We give it the server, so the implementation of that API, and it does the whole validation at build time. So as long as our business logic is correct, the API is correct. And one actually very neat thing is that when we add a variable that we capture, doesn't matter if this is a body or if this is a request variable or if this is a query string variable, we're getting another parameter on the handler, on the implementation. So if we have an endpoint like users that does not accept any parameters, it just lives in the handler monad. If it accepts parameters, those parameters become parameters of the handler function. So we don't have to get the parameters from somewhere. They're already there and very easily accessible. If this is a query string parameter, this is also a maybe of a parameter because it might not be there. It's not obligatory. But with these, it'll also validate that those parameters exist. It'll only accept the request if those parameters exist. So we'll always get the data that we expect. And to show you that this is actually doing what it's doing, if we change the type in here to, I don't know, text instead of UUID, and we try to build it, we'll get an error because it cannot match UUID that we have in the implementation with the type that we have in the API definition. So it's also fairly easy to create an API definition that we know matches a spec, and then it makes sure that we don't make a mistake when implementing the actual endpoints. So we have the endpoints now that allow us to get the users. There's also another part that will allow us to actually talk and share the information on the position of our heroes. This lives in the WS file, where we have a WebSocket implementation. I mean, an implementation of our WebSocket protocol that basically loops and checks for every message if it contains a command, and then it broadcasts that command to all of the other users. In our case, we're going to broadcast a position of our hero and maybe some other data later if we decide we want it. The protocol that I've written here demands that we first say who we are, and it will then allow the client to send the data and broadcast this to everyone. There's also some boilerplate code here, like pinging every 30 seconds so that the browser doesn't disconnect. But that's not really relevant. So let's run the server side. Actually, can you all make sure it builds for you first?
It built and ran for me without issue.
Nice.
So what you have on the repo is probably fine.
Great. I also want people to get the packages.
Yeah, the first stack build takes a bit.
Yeah.
It's probably like 5 minutes.
Yeah, so once they start, I'll... So Servant is very easy once you know it, I mean, as everything, right? But you need it to click. So how about you choose an endpoint that you want to add here on your computers, and you add an endpoint. And you try if it works for you. If it breaks, just ping me. I mean, say that it broke, and I'll help you. So what you have to do is you have to add an endpoint here. You have to add an implementation in here, and you're good to go. You can curl it to test it. I guess that's the easiest. It can use the accounts that we have. To add a new account, you have to post onto the register with a name. Let's try having a split screen. Yay. Okay, this works. So we can curl exposed. Okay, so the parameter name is username. All right. Oh yeah, we need the header. Yeah. Nice. So we got a UID, we got the username and an empty score. And now when we query, we'll get the users. And the cool thing about the ACID state is that they're there forever. So I've just restarted the server and we get the same users. But that's irrelevant here.
What is that actually doing? Does it have a local file that's just writing stuff
Yeah,
to? Yeah,
so it's writing into the state folder.
Got it.
And it has some files. One limitation of ACID state is that the data you're operating on has to fit in memory. So it's perfect for users like that. I'll get some water. So your internet card still doesn't work.
definition for like a simple GET request that doesn't expect any parameters, do you always have to tell it you're receiving JSON?
Yes.
Like the user someone does?
Yes.
Okay. No way to tell it nothing, basically.
Oh no, so this doesn't say you're receiving JSON, it says you're returning JSON. Here. So the types that you support on the return value is JSON. I don't know, I've never actually tried putting an empty list here.
I just
Give
spit
it a
back
try.
a string when I had it defined like that and it didn't complain. It didn't actually give a JSON. I just had it.
Oh yeah, because what it'll do, it'll take the string and put it out as a JSON string.
Oh, okay.
So it'll automatically convert it.
It doesn't have to be an object.
Yeah. It's a bit of a loose deserializer. Oh yes, because I've kind of assumed everyone's going to know what to do, but it's not obvious. So once you get this, you need to do stack install. Then you need to stack build, and to run you do stack exec. What's the name of the application? Server-side exec. And those commands will allow you to run it. And then to test it, you do curl, or you can use Postman or whatever you like, right?
What's the pool?
8081. Yeah.
Sorry, could you also share the sample curl command you had up for feeding stuff to register? I always forget how to actually give it the...
You mean how to give it the data?
to hit the register endpoint to actually add a new user.
Oh, yeah, I'll just write it here.
That's it.
Actually, yeah, this is wrong.
That works. Thanks.
Great. So, has anyone added an endpoint successfully? Okay. We'll wait 5 more minutes. So what kind of endpoint did you add?
It's just foo bar. It's called foo. It gives you back bar.
Sure.
Not complicated.
You can,
There's something material to do.
yeah, you can try adding parameters or something.
Trying to think of something useful to add at the API level, but we've got most of what we need for simple stuff, because if you want to like show a leaderboard, you already have all your
Yeah, the comms is
users and
through
all that.
WebSockets. It's probably subtly broken. I haven't actually run it, connected it together, but we'll do it. You might add a delete on the user if you want. Yeah.
For score, what's the HTTP method for score?
Oh, so this is a put.
Okay.
So this bit is the whole what score does. It captures a parameter. So you do score slash the UUID as a string, and then it also needs access to the body, and that with that type, and you need to do a put to get to it. So if you want to,
Do you guys have a request for that?
oh, you just do x put, and then, yeah. So let's see what kind of the type we need. Okay, so it's just a new score.
Oh, do we have anything that actually distributes like so color is one property that a user might have that we don't have here yet, right?
Yeah.
We can have that. Probably.
How would you define a route with a query param that takes like comma separated list of values?
So you mean a query param that's
For example,
a list?
yeah, UUIDs that would be separated by a comma.
So what it supports the bracket notation. Let me just finish this one and so in here you have to pass the UUID here.
Put score first.
Well, the score goes in a payload in the body, and then the UID goes in the path.
Slash score slash.
Oh yeah, you're right. I don't remember. Okay, so it's query params. So let's see if this builds. So say we want a list of UIDs. It didn't make some sense. Okay, and let's check if this doesn't error out. I think this is the notation supports. Yeah, it is. Yeah, and this will 404 because there's no. Actually, yeah, there's no endpoint. Okay, this is a bad request because this does not deserialize, but at least we can hit it, so this works.
So ACID probably has some sort of migration system for when I add properties to existing objects, right?
The migration system I've used is remove the directory.
That works for me. I was going to say I can do that. Everyone else is going to have to do it too.
So score expects one log parameter UID and one UUID scoring parameter also.
Well, right now I've added it as a to show something, but it accepts a list of UIDs in this case, which you supply by having this multiple times and using the brackets.
Okay.
But that's not reflected in the type there? That's correct?
You mean?
I mean that you use the plural of UUIDs, but then in the type you only use UUID, right?
Yeah, because so query params with an s at the end, it'll make a list out of the type that you can pass here, and then the actual handler will accept a list of UIDs.
Okay.
So after lunch, we're going to bind the front end to the back end, and we're going to see if we can actually get the other user from the other browser. So if we can actually get a multiplayer game running. Oh, some kind of technical details is that the handler monad, it has I/O, so it's a transformer that has I/O, but it's not I/O itself. So whenever you do I/O, you have to lift into the I/O. I just realized that there was less people yesterday, so some of you might not actually have the address of the repo.
It was in
It's in the chat.
Discord though.
Okay, great. And also a hint. So this is a term level operator, and this is a type level operator. They're the same as in text, but they're a different thing. So you have to.
What's it a servant state operator called?
You mean this operator?
Yeah, you told that is actually type level operator. What
Yeah.
is this one? Another one?
Oh, it's an operator you use to chain different endpoints.
Okay.
So the alternatives. It uses the alternative. It looks like an alternative because you use either one endpoint or the other.
Okay.
And for those of you that have conflicts, if you could get those resolved at like 10 minutes before the end of break, I'll merge all that don't conflict then.
loggers on the server.
Nice.
Works. Pretty similar to updating your score, so it's not rocket science.
I mean, it's just a REST endpoint, so, you know.
It's true, at the end of the day, it is all just HTTP, except for WebSockets.
Just still technically. Right? So you'll make a PR, right? And then I'll merge it.
For this on the server, yeah.
Yeah.
Make sure you get the Konami code first, though. It's more important.
Of course. Yeah, it's past the break time, so feel free to break at your convenience. It should be lunch at the moment. Okay, and I'm also using a middleware here to get the course headers, since it's on a different part, and Webpack didn't really proxy the request for me. So you use the middlewares as you would normally. You just and they intercept the requests, and they just add the headers to all the responses. So I've merged the Konami code here, and we'll.
It works. Cool.
Great. We'll try to. Actually, let's get my changes. We'll try to glue the back and the front. Let's get this running. Oh, it is running. Cool. Yeah.
And that also has the color endpoint in there as well, so you can put color, and that puts an example curl in the pull request.
Oh, so you've included it in the Konami code pull request?
Yeah, the color stuff is in there. Yeah.
So let me see.
It's basically exactly the same as the score endpoint.
Okay.
Wasn't hard.
Okay, so let's see what we have now.
I'm also not enforcing what you can put in there at all. It's just a string.
Yeah.
Maybe you can just throw that on the CSS property and be good.
Mm-hmm.
Or I guess it's the color you draw into the canvas in this case.
I mean, it's essentially the same thing. It's a paint property. So I decided to sketch the sketch of a solution first because it turns out it's actually way less obvious than I thought at the beginning, and you would have spent an hour looking at the docs. So I've created a binding to request promise, which is this kind of standard library to I mean, it's a library like in JavaScript to make requests. The whole binding is in the RP module. Basically, we have a type-safe request name that gets deserialized to that string. It uses polymorphic variants, which are like variants, but they can exist on their own. So the difference is that this isn't really a part of the request method type. The request method is a collection of those types. It makes the variant itself slightly more malleable in the sense that you can have another type that has 3 of those, and it would accept 3, but it wouldn't accept the other one, and they could still share the name because the polymorphic variant is independent of the type that contains it. And the request has a URL and it has a method. And we just query the request promise module, and it returns us a promise of something, which is the response. And then to actually make the request, we make it here. So we query the user's endpoint with get, and then we get the value, we parse it. There is a couple of parsing libraries in Reason that do type-safe parsing with parser combinators, but that would be a lecture on its own. So we're doing the thing that you shouldn't, and we're just doing JSON parse and then pretty promising that this has the type that it should. So we parse it into the user structure. The user has a color now. Yep. No, that's not the editor. Oh, crap. And let's see if this works. So we should get a response somewhere here. But we didn't because we're not running the server side.
You probably have to wipe out your data too.
I wonder what it'll do.
Gave me an error.
Oh, okay.
It's a version mismatch, I think. I guess ACID versions your
Yeah.
data schema.
It is complaining. Okay, cool. Okay, so we get an empty list of users. Let's add a user. Okay. And we get a user from the server side into our reason code. So this is good. We can now do interesting things. So let's find my Vim. There we go. So first thing we should do is register the user. So we don't really care about whatever. So we're going to, every time we start it up, we'll register a user, and then we'll use that user for subsequent requests. So let's make a request. How many of you are familiar with promises in JavaScript? Good. So this is the standard promise interface with chaining. So we can actually make it a little bit more readable.
So what are promises?
Promises is a wrapper that gives you a value at a certain point in the future, or gives you an error. So in this case, in the then callback, we'll get a value that this request returns. But because in Node you have an event loop, so you don't get threads, you can either block the whole event loop and not have anything happen in your program, or you have to wait for your value to come around. And promises are a reasonable abstraction that allow you to act when you have that value.
And
So,
then is a bind.
yes, and then is a bind. You could think of it as a monad with errors. So it's effectively either, but asynchronous. And we need another awful parser like that. Actually, now we can reuse the same parser. Cool. And we need the payload. We need to add a payload method to the request. And the payload will be the payload. It's just a username. Though I think it's called data in this library. So you can here use, technically you can use an abstract wrapper to generate the setters and the getters, but there are two issues with this abstract wrapper. First of all, it's not recursive. Second of all, it doesn't work if you have two data types that have the same fields. Even though it shouldn't break like that, it looks like a compiler bug. And then in here we have to serialize our data. How do we call our hero? Let's him be Mario.
You say Mario in Polish.
Yeah, it is Mario in Polish as well. And then let's see if this works. So we can remove this request and see what this gives us. This is Webpack, so this is the compiler. And we have a syntax error like 20. Oh.
Do the dots after the open brackets belong there? In internal request? So bracket
Yeah,
dot-
yeah, because this is a JavaScript object and not a record.
Got it.
Let's actually, and cool. So this compiled. Oh, it's called body, not data. There we go. And then we also need, in the internal request, we need the JSON field, and that's Boolean. And we'll set it to true forever. So there are, unfortunately, very few bindings to JS libraries, and when it comes to DOM, there are no bindings to WebSockets I could find. So this is actually pretty good for our exercise here. So let's see what kind of request it does. Oh, we don't get the button.
It's missing the content type, right?
Yeah, and it doesn't have any body as well. So let's see. Oh, we're actually logging the payload. So let's see what we have here. Okay, this looks reasonable. Oh, it's still called data. Because there is a compiler. RP request. Okay, well, if we have to do it like that.
It's where you make the request itself at the bottom with Mario.
No, it's just complaining that this field does not belong in the request. And I think what we'll have to do is do like that. Oh yeah, you're right. Is it line 59? There we go. Okay, let's leave that complication in. And we're getting a bad request. Username, and I think the Haskell code expected something slightly different. No, it's username.
Was it options that failed? Was it a course issue?
No, the course would give us a course error. Let's see what requests we're actually posting. There's no content type.
It's warning about access control allow.
Yeah, you are right. Which is weird. Okay, so this way we're going to remove the registration requirement from our WebSocket, and we're going to just connect up the WebSocket. Okay, so we're assuming that the users always exist. So in order to get WebSocket working, we need to bind into the global WebSocket object. Now because the binding is very similar to the binding of the date, let's just copy it over and let's call it WS, and we're going to create it with the WebSocket. So let's try it. So we're going to do WebSocket.create, and then this actually accepts a string instead of a unit, and the string is the path of our WebSocket. And let's remove the part where it calls and files. I'll get the fix later. So, okay, that's building. Oh, it's WebSocket with the other case. Oh, and this is not HTTP. Okay, we have a socket. So, what does our protocol demand? Let's check. Our protocol accepts a connect message. Then it doesn't actually check if the account exists because we're saying it always exists. And then it does things. So let's see what the connect message contains. So this is an action message. So we need to provide a JSON object that has the action field that says connect in a string, and then we need a UUID that won't be checked, but it'll most likely be validated against the UID type. So we'll have to get a UID in a second. In order to get the connect, actually we need to send some data here, right, on the WebSocket. So the WebSocket has two methods on it. It has a send that for us will just accept a string of data. So we do the bs.send that has nothing to do with actual send. And this is going to accept the WebSocket that we've just created as the first parameter, and then a string that's going to be the data that we're sending over. And it will return nothing. And the method itself is named send. So what it's actually doing when we call it now here, when we call it here, this will build to something like ws.send blah. So the send decorator takes the first parameter, puts it before the dot, and then takes the rest of the parameters and puts them as function arguments. So let's send a JSON object, and we need the way to stringify that request. So first we need the request type. That's just, we won't make it beautiful, it'll be a raw object. That's going to have an action. That's for now going to have a string. And it's going to have a UUID. It's also a string. And then we do take this hack and put it here. And we have to put it after because it doesn't do what Haskell does. So now we can stringify, so we couldn't do but if we send it, we won't actually receive the message in any way, so we have to bind into the, I think it's called on message. Yeah, event listener. So let's make that binding as well. So the type T, do we want to, yeah, let's do it through the send. There are two ways to do it. We could either make the type T be a record that has a method on it, or we could use the send external. Let's use the send external. And this was will accept a callback that's going to accept an event. So it accepts a function from E to the unit, returns a unit, And so the reason why we use an empty string in here, but this filled string in here, is that if the method name is the same as the method name in JavaScript, we can just use an empty string. If the method name is different, like here, we put the method name in the string. So we can do WS on the message. And we return the unit from here. And the event itself has one interesting property on it, which is data. So that's what we're after. So I think the easier interface here is to just make this a record with a type data, and this is string. This way, we can just JS log event data. Actually, and this is not a record, this is an object. So we use the double hash. And we get the error 279 because we didn't close the bracket.
Did you put a dot on purpose in the record?
Yes. So this makes it a JavaScript object. If you use the dot and then the quotes on the field names, this becomes in the representation it becomes a JavaScript object. You shouldn't use it for anything else other than interfacing with JavaScript. The standard records are actually very performant in their representation in runtime because it's just a list, an array of the elements, and there's no type or key information involved. So they're very compact. So this takes a request and outputs a string, not stringify. And the onMessage binding needs our type as the first parameter. Okay.
Shouldn't you connect the onMessage before sending?
It won't be synchronous, but yeah, in principle, yeah, definitely. Oh, this is in a still connecting state. So we unopen. There is another listener, so we can just and this takes a function of unit to unit because we're not really interested in what it's doing, and we're doing WS on open. And we'll send it once it's ready. Yeah, this didn't rebuild. Sometimes, I don't know if it's just me, but sometimes the reason compiler doesn't pick up a change, and you have to reload it. It's even more frustrating because at times this change might be an actual bug, and like a build breaking bug, and it won't be noticed until you save again. There's no onMessage function? Oh, because okay, so this is not a function, this is a property. So the send is a function, but the unopen and onMessage is a property that we have to assign to. So we have to make this an object with a mutable property onMessage, and that's an event to unit, and we also have a mutable. I think it's. I don't remember. There's another mutable property on open. And we assign to the mutable. Oh, it's called mutable. Oh yeah, and this. Okay, so this is what I'm using. Okay. And for the types to be mutually dependent or recursive, we need to actually do this. And this is now the record. Because it's an object. Whatever. Works. But it did not update the files. See? Ah, now it's a bug. It didn't work. 282. So yeah, so this one works, the other one didn't. Cool. Okay, so we got a response from the server. It said it got a wrong message format. So let's see what, actually, how are we doing with time here? Okay. What kind of message format does it demand? So it's an action message of connect and the UID. Oh yeah, that's most likely because the UID doesn't deserialize because it's not a UID. So let's get ourselves a UID maybe from here. it won't actually be checked. And now we get nothing from the server, which means it's great. So it works. We got connected and we most likely got accepted into our main loop. So we've broadcasted to all of the users other than our connected user that the user has connected. If this is true, we should get, I wonder what will happen. When this user connects, we should get a broadcast here, but we didn't. Oh well. Anyhow, let's see if we can, if the main loop works. So in the main loop, we receive the data, and then we broadcast the message. So the data we receive goes into the process message, so it gets an action message, and if it's a valid action message, then it broadcasts this everywhere. So again, our action message is an action. So let's say our action will be, we should actually now add a new action. With a position update, right? So that other users can know where we are. The UUID we have on the action, so we just need X. I wonder if we should use a float here. Yeah, let's use a float. So this should add a position update for us. Sorry?
Why are you not using stack rank?
I don't know. There's no command called run in my stack. So, okay, we've sent this one message, and then we can try sending first a manual position. So, the option will be of a wrong size here, so let's say make it generic. It'd be wiser to make it generic instead of copying it over all the time. So Oh yeah, and we have to add. And now will never deserialize into our position update. So we do position update, and in here we do serialize into a position update. I think the syntax was like that. It might be just easier to derive the instance. Okay, because the instances are now derived, we probably have to change the names to the uppercase connect. Okay. Let's keep the same UID. Oh, so action will be an object now. Cool. Okay. It's the wrong message format, but what is the right message format now? Well, can always check. update request. So action message connect. Okay, so we need a tag, and then for the position update, we need a tag and then the speeds. Okay, this is easy. Okay, and in this section we need a tag. To connect.
Do you not need a record there too? The
Yeah, hold on, I've lost my editor. There we go. Yeah, I need the dot. Okay, so we've sent the position on connecting. So let's go into hold on. I think I know why the sending, why in broadcast we're filtering for the same UID, but we're connecting with no UID actually. So let's just not filter and use the state in here. No, I keep on doing stack run.
sorry.
No worries. Okay. Okay, so we got our own stuff. So let's try to connect from another instance, and we got the data. So with the wonderful management of time when live coding, we didn't quite get to the state where we can see other users playing, but we did get to the state where we can get the messages from other users. And now what's left is binding this and sending a message on each frame, because we don't care about the CPU or network. Sending a message like that on each frame with our UUID, and then updating, instead of taking the position of other users from a list. So actually, where's the world type defined first? Yeah, so we have a list of heroes, and we could then have our hero as the first element and then create the rest of the elements from what we get over the network. The fact that in here, I try to be smart and, and in here we'll animating both of the users, right? So in that case, even if there is a network lag or stutter, we would still have the other user behave as if there was a network connection and he didn't do anything. He would still be animated. Which would be neat once we get the connection working, but I'll probably do it after the weekend. So if you want to see, you can check out the repo there then. Thank you. And how's your... did you all manage to get the stack program working with your changes? I'm glad. So stack is not... I mean, The errors sometimes can be tricky, but it doesn't bite.